2013 physics paper. 31st question. In the circuit R1 equal to R2, the value of R1 is mentioned, R2 is mentioned, this is not mentioned, therefore incomplete question, grace marks. 32. Masses of the wire of copper are in the ratio, this is M1, M2, M3, and lengths are in the ratio 5:3:1, L1, L2, L3. Resistance of the wire is equal to resistivity length by area, or resistance is proportional to L by A. But density equal to mass by volume, mass by area into length, therefore area equal to M by L, this is density. So area is proportional to mass by length, therefore resistance becomes, or resistance is proportional to L by A, which is also equal to L by M by L, which is L square by M. Resistance is proportional to L square by M. L square 5 square by 1, 5 square by 1, 3 square by 3, 9 by 3 is to 1 square by 5, 1 by 5. This is 125, this is 25, is to 3 is to 1 by 5. We don't want 1 by 5, multiply through by 5, therefore 5 into 25 is 125. So it is 125 is to 15 is to 5. This is the answer. For a transformer, turn ratio is 3 and its efficiency is 0.75. Current flowing in the primary of the coil is 2 ampere and voltage applied is, if this is a transformer, primary, secondary, turn ratio is 3, input is 100, then output is 300, because turn ratio is voltage at the secondary by voltage at the primary. Voltage at the secondary is turn ratio times voltage at the primary. So turn ratio is 3 times 100 is 300. It is also given current is 2 ampere. So current at the secondary is wanted. Efficiency equal to power at the secondary by power at the primary. Implies power at the secondary equal to efficiency power at the primary. Efficiency is 0.75. It is mentioned. 0.75 is 3 by 4. Power at the secondary is current, power at the primary is current and voltage. Current at the primary is 2 ampere. Voltage at the primary is 100. Power at the secondary is current, voltage, secondary. Current at the secondary wanted, voltage at the secondary 300. So in this equation we have to solve for current through secondary. 300 get cancels with this 300, 2 by 4 is 0.5. So 300 volt and then 0.5. 0.5 is the answer. A proton and a helium nucleus are shot into magnetic field at right angles with same kinetic energy. Here charge particle is moving perpendicularly or entering a magnetic field perpendicularly. Therefore QVB sin theta equal to mv square by r. This is the expression for force on a charge moving with velocity v in magnetic field B. This is 90 degree, means it is mv square by r. Sin 90 is 1. Solve for r equal to this one velocity get cancels, mv by qb. Okay, numerator is momentum, mass into velocity, but they are shot with same kinetic energy, or entering with same kinetic energy. So momentum in terms of kinetic energy is square root of 2m kinetic energy by qb. This radius is proportional to square root of m and charge. So radius is proportional to square root of m by charge. For proton, unit mass 1 under root, charge of proton is 1 unit, 1 divided by helium, 2 protons, 2 neutrons, therefore mass is 4 unit by there are 2 positively charged particles, therefore 2 unit. This get cancels with this, answer is 1:1. 1:1. 35th. Two identical circular coils A and B are kept on a horizontal tube side by side without touching each other. If current in the coil A increases with time, in response coil B, this is a tube, these two are two coils kept side by side. If there is current in the primary, current increases, then this should repel this. It is to conserve energy. So to conserve energy, it should be repelled. 36th. In the diagram, there is a circular coil carrying current I1, straight conductor with I2, strengths straight conductor respectively OA, OB, R. Net magnetic field at the center is 0. Ratio of currents in loop to straight conductor. Okay. So magnetic field produced by circular coil at the center is equal to magnetic field produced by straight conductor. So field produced by circular coil should be equal and opposite to field produced by straight conductor. Okay. Now magnetic field produced by circular coil is constant 2 pi Ni by R. This constant is mu naught by 4 pi. Similarly, due to straight conductor, magnetic field at a point is constant 2I by R. This distance is R plus R, 2R. Radius of the circular coil is R. This constant is again mu naught by 4 pi. Constant get cancels. R get cancels. This is I1, I2. Therefore, I1 is to I2 is I1 by I2 equal to 2 get cancels, 1 by 2 pi. 1 by 2 pi. Two tangent galvanometers. Galvanometer. This is not there in NCERT syllabus. 38. A charged particle with velocity 2 × 10⁻³ passes undeflected through an electric field and magnetic field mutually perpendicular. So it comes under velocity selector. Velocity selector. It says velocity equal to E by B. So we have to find electric field. Velocity is 2 × 10⁻³ electric field by magnetic field. Magnetic field is 1.5 Tesla. 1.5 into 2 is 3 × 10⁻³. Next, 39. In LCR, the potential differences across each element is 20 volt. Now the value of resistance alone is doubled, then potential difference. It's a beautiful problem. It is L, C, R connected to NAC. Potential difference across them is 20 volt each. 20, 20, 20. This voltage is opposed by this voltage, therefore they get cancels. This is the applied voltage. So applied voltage is also 20 volt. Okay, fine. Now resistance alone is doubled. Again, inductor, capacitor, resistor. This is the source. Applied voltage is constant. If only resistance is doubled, if it is 2R, again potential difference across the capacitor is cancelled by potential difference across the inductor. This is equal to this, therefore 20 volt. So potential difference across the resistor is 20 volt. So potential difference across R, L and C, 20, 20, 20. So this is not the answer. Okay. So we have to choose among these three. Since applied is 20, the potential difference cannot be 40 across these. Therefore, this is ruled out. 20, 20, 20 is true only when resistance is R. 20, 20, 20. Therefore, this is ruled out. Correct answer. This is called elimination technique. A rectangular coil of 100 turns and size 0.1 is placed perpendicular to magnetic field. If the field drops to 0.05 Tesla in 0.05 second, the magnitude of the EMF induced in the coil is, okay, EMF equal to minus d phi by dt. EMF equal to minus d phi by dt minus d by dt. Flux is number of turns area magnetic field into NBA cos theta. Okay. Placed perpendicular to a magnetic field coil, is it plane of the coil or area vector? It is not clear. Therefore, grace. Let us try to think that theta is 0 degree. If theta is 0 degree, cos 0 is 1. Okay. Therefore, area B, it is dB by dt. So this is the EMF. Number of turns is 100, 10 power 2. Area vector 0.1 into 0.05 is 5 10 power minus 3 dB by dt. Magnetic field drops from 0.1 Tesla to 0.05 Tesla. So the difference is 0.05 by in time 0.05. 0.05. This get cancels with this. 5 10 power minus 1. So it is 0.5. That also not here. In the circuit diagram, heat produces in R, 2R and 1.5R are in the ratio. Now, 3 resistors, R plus 2R is 3R. Let total current be 3I. Okay. Therefore, this current is 2I. Lesser resistance, lower resistance. Therefore, higher current 2R. Let this current be I. Now, if these two are in parallel, then potential difference across them is constant. So 2I into R, 2R into I. So potential difference is same. And current through 1.5 is 3I. Power dissipated is current into voltage I square R or else V square by R. We have resistance and current. Resistance and current I square R. Let us use I square R. I square R, 4I square into R is power dissipated by first, is to power dissipated by second, I square into 2R, I square into 2R, power dissipated by the third, 3I whole square into this, 3 square is 9, 9 into 1.5 is 13.5, 13.5 I square R, I square R. 13.5 multiplied by 2, it is 27 is to 4 is to 8. A series combination of resistor capacitor connected to an AC source of angular frequency omega, keeping voltage same if frequency is changed to omega by 3. Current equal to voltage by impedance, voltage by impedance is root of 1 R square plus X C square. It is resistor and capacitor. Therefore, current is equal to voltage by root of R square plus 1 by omega C square. Okay. Ratio of the capacitive reactance and resistance. Ratio of capacitive reactance and resistance means Xc by R is wanted, or else 1 by omega C by R is wanted. If frequency is changed to omega by 3, current becomes half. Current becomes half if frequency is changed to omega by 3. Omega is omega by 3, then V by root of R square plus 1 by omega by 3 C square, which is equal to V by root of R square 3 square is 9 goes here, so it is 9 by omega C square. So this square is only for omega C. Okay, now we have another expression. Let me divide this by this expression. I by 2 equal to V by root of R square plus 9 by omega C square. I get cancels, V get cancels, there is square root, therefore let me square the entire equation. Actually I am dividing this by this. This 2 goes to numerator with square, so it is 4 equal to, this whole thing goes to numerator, R square plus 9 by omega C square by this R square plus 1 by omega C whole square. So we have to solve for 1 by omega C and R. Cross multiply, it is 4R square plus 4 times 1 by omega C square equal to R square plus 9 by omega C square. Okay, 4R square R square, 4R square is 3R square equal to 9 times 4 times, this is 5 times 1 by omega C square. Now we want 1 by omega C R, let us take square root, we get 1 by omega square by R equal to 3 by 5. This 3 by 5 is nothing but 0.6. Then we take square root 3 by 5. 3 by 5 is 0.6 under root. Of course, it is taking time greater than, slightly more than 1 minute. Okay. 43. Pick out the correct statement from the following. Mercury vapor lamp produces live emission spectrum. This is out of syllabus. Not required. Okay. This is not in NCERT syllabus. Light emitted during the de-excitation of electron from 3 to 2. When incident on a metal, photoelectrons are just emitted from the metal. In which of the following de-excitations photoelectric effect is not possible? This is the energy level diagram. Energy levels are crowded as n value increases. Fine. 1, 2, 3, 4, 5, etc. Transition is from 3 to 2. Then energy is sufficient. 3 to 2. This energy is sufficient to remove electrons. Okay. Now, in which of the following de-excitations photoelectric effect is not possible means energy should be less than this. Fine. Transition is from 2 to 1. Just observe, length of this is greater than this, nothing but this energy is greater than this. So emission is possible, therefore not the answer. From n equal to 3 to 1. 3 to 1, even this line is longer than this, therefore photo emission is possible. Yeah, photo emission is possible and not the answer. From n 5 to 2. 5 is here, 2. This length is also greater than this, nothing but energy of this de-excitation is greater than this, therefore emission is possible, not the answer. This is the answer. 4 to 3. Just observe, 4 to 3, this length is smaller than, this means energy in this de-excitation is smaller than energy in this de-excitation, therefore 4 to 3. The additional energy that should be given to electron to produce or electron to reduce its de Broglie wavelength from 0.1 nanometer to 0.5 nanometer, means half of it is reduced. Wavelength is given by h by, it is in terms of additional energy, square root of 2me. So lambda is h by mv, one equation. Lambda equal to h by root of 2me in terms of kinetic energy. Third equation, 1 by root of 2m charge into potential difference. Okay, we are using this equation. 0.1 nanometer to 0.5 nanometer means this should be by 2, means by 2. This 2 goes to numerator, means h by root of 2m 4e. 2 is taken inside, it becomes 4, therefore 4 times e. Energy is increased from e to 4e, then lambda becomes lambda by 2. What is the increase in? Increase in energy is 3 times, therefore it is 3 times the initial energy.